Good afternoon.
Afternoon, Scotty. How's things, mate?
Well, it's a little bit cold today. I have to say I'm not enjoying it, but I get to wear winter clothes for once.
Today we want to talk about guts and inflammation and autoimmunity, aren't we?
We absolutely are. And we're going to then have a little bit of a tinkle with sleep detoxification and the effects of how, stress and the immune system and your adrenal systems will affect some of that. So I came across a really cool paper, which I'll bring up this moment in time, which I think is really quite fascinating. Just the title alone kind of grabbed my attention. And this is only a couple of months old. 12 months old, May 12th, 2020. I haven't seen any follow-up on it. But it's quite fascinating insofar as this group of researchers has been looking at the effects of the gut-activated lymphoid tissue in response to, food allergies, autoimmune disease, and chronic infection, especially viral load, which is pretty interesting considering the current pandemic. And I'm certain that must have been what brought their attention to it.
The gut lymphoid tissue being these cabbage patch looking things that I'm looking at right now.
Yeah. So the lymphatic system is part of your immune system and it's part of your cleaning systems in the body. So it's basically a filtration system. And you've got these villi fingers. So on the gut lining, you've got fingers that come up, and on those fingers, you've got microvilli that kind of come out, and they're called the brush border. And they give it much, much, much more surface area for both digestion of food, absorption of food, and the cleaning of debris. Now, in those microvilli, every one of them has a lymphoid or lymphatic duct. So it's got a tube that basically sucks stuff from the gut into the body, either for cleaning or in the case of fat, it moves fat from the gut into the lymphatics, into the bloodstream to actually create digestion in the liver, which is kind of cool. But in this particular instance, we have these nodes, sentinel nodes, which are these green things here, and these are the villi around it, called Peyer's patches. And the Peyer's patches are capable, as it turns out, of forming these antibody responses. And this particular group found that the gut is making antibodies to tone the response to infections, tone the response to food, but also it can be chronically activated. And it's kind of quite a fascinating concept. So the gut was found to make these subsets of antibodies even when there wasn't a stimulus. So it suggests that there was actually something going on that we didn't even know was going on. And that could be some degree of triggering from chronic stress or inflammation or effect elsewhere in the body, or potentially something went on like a virus got into you, and that virus triggered the Peyer's patches to keep upregulating the production of these antibodies all over the place. And that's, I think, what they were talking about with this, the COVID infection, is a lot of the people who've had the COVID infection have gastrointestinal effects of it after the fact. And they're talking about that in this long COVID syndrome sort of patients, they have a lot more irritable bowel afterwards. And this may be something to do with the mechanism. But ultimately, I found it particularly interesting. So again, the Peyer's patches are shown to not be static tissue. It's active tissue constantly being bombarded by food and viruses and bacteria, stuff from the outside that the body has to go, you're not me, I need to kill you and punch you in the face. Now, the gut itself, as they note, this is fascinating. Think on that. There's 40 trillion different bacteria in your biome. Whether they're good or bad is a different matter. But they've just got 40 trillion is the guesstimate here. And that's supposed to be more bacteria in your gut than are actually cells in your body. And
so Peyer patches will activate in the presence of a bacterial infection that's not supposed to be there, wake up and punch said bacteria in the face.
Pretty much.
But then ideally should go back to sleep unless there's a viral load and or stress load and or inflammatory load of some description going on.
That seems to be it. So again, this particular paper is actually suggesting that they're operating as an immune sensor, and so that they're never really fully going back to sleep, so to speak. They're constantly active and trolling, but if there is a real threat, they start making an antibody response. Otherwise, they appear to be making this constant subset of certain antibodies to tone your biome and say, hey, stop growing. Too much of you. No, not you. Okay, we'll allow that one through because we need, and it seems to be almost a bit like a conductor for a symphony orchestra.
Gotcha.
So, yes, you're good over here. No, stop. And it controls the amount of bacteria that we want going on. Now, that scenario will be, again, affected by foods going into you, the amount of environmental stress, other toxins, and again, it's going to be affected by your nervous system because what we know is that imbalance of the hemispheric model of the brain, where we get much more left brain activation and suppression of the right brain balance, is shown to affect the vagus nerve. And when it dysregulates the vagus nerve, we can get, again, dysregulation of the gut and the gut lymphoid tissue in the immune system and chronic inflammatory responses. We get a lot more adrenal type activation with a lot more cortisol and a lot more adrenaline coming in, and that's shown to cause the tight junctions in the gut lining to start to leak. Now, the problem there is as soon as the gut lining starts to stretch apart and you get gaps in it, some of those bacteria can get into the bloodstream, and that will activate a secondary cascade, which then drives more antibodies to being produced, which then causes chronic inflammation because those antibodies are now in your bloodstream, not localized in the gut itself. And this means that they can go anywhere that the blood goes, which includes the brain. So it becomes a wind-up loop at that moment.
So we've got payer patch inflammatory response, but then in the presence of a chronic inflammation, left brain becomes overactive, which drives vagal nerve dysregulation. We then start to see leaky gut or gap junction misbehaving, allowing bacteria or partially digested food particles to go through said junction, and then we're getting antibody response in the blood as well as in the gut, perpetuating everything else.
Correct.
Is there a feedback loop thing the other way? So if we've got gut inflammation creating antibody response in the blood, creating a brain response, does it go the other way where a inflammatory response in the or antigen levels in the blood will have an impact on payer patch activity?
Not so much that way. The payer patches are outward facing, so they're only facing into the gut. But you're quite right, because what we originally described is called the outside in model. So the inside out model says that brain dysregulation because of something like, primitive reflex retention or chronic emotional stress, like your mum died, or you just lost your job, or you got locked up in quarantine for 2 weeks, or such fun, which drives your brain to be acutely defensive, which causes this left-right brain imbalance, which dysregulates the vagus nerve, which sets up the gut to become chronically activated and ready to fight whatever is going on. So sometimes the gut bacteria are perfectly fine and the food environment in the gut is perfectly fine, but because of that inside model, the brain dysregulating in the first place, it sets all of it up to become problematic, and then that starts a loop going on, irrespective of how well you're actually eating. And this is one of the things that I observe in some of my patients, where they're coming and going, look, I'm eating as well as I can. I'm on this diet. I've got no gluten, no dairy, no histamine, and they're doing everything arguably perfectly, yet they're still getting chronic gut symptoms. And I think rather than it being the outside in model where you ate poorly or you've got bad bacteria or otherwise, it's because the brain is dysregulated in the first place and has got into a chronic wound up loop. It's been afferentated into a corner. And we need to be doing neurorehabilitation, not just, gut brain axis rehabilitation, if that makes sense.
Yeah. So elimination diet doesn't work. We need to look at it from a brain down impact rather than a gut up. Yeah.
Absolutely. And so again, what they were doing they wanted to try and figure out why were these chronic antibodies being produced. And so they found that there were a basic subset of about 10 major types. And again, I think realistically, what a lot of them are meant to be doing is that they're meant to be being constantly produced, as it notes here, as a sentry to maintain healthy gut activity. So you've got a system that's always, to some degree, in a defensive mode to make sure that those bacteria aren't overproduced, out of balance, creating, like, again, we kind of think about things like strep or staph being bad guys. And these are things that we get antibiotics for if it gets bad enough, right? So strep and staph are commensal bacteria that are part of the normal biome. I see it all the time, but they're meant to be within a certain limit. And when they get above that certain limit, that's when we start to see infectious problems or brain problems or inflammatory irritation, skin problems, etc. They cause symptoms elsewhere. Now, this particular paper is suggesting that the reason that's allowed to occur is because of a failure in these Peyer's patches sentinel systems to actually tone and regulate the bacteria. Now, the question mark then becomes, is it a lack of resources at the front end, at the Peyer's patch, or is it a lack of brain resource? There's not enough signaling to tell the immune part of that nervous system, the vagus nerve, to actually do the job and appropriately regulate at that moment. So I don't know, but again, what they were finding is disturbances in this particular balance was shown to cause the development of inflammatory bowel and autoimmune diseases. So that would be, potentially lupus, potentially a thing called PANDAS, pediatric autoimmune neuropsychiatric disorder acquired by strep, or again, Crohn's disease. Now, these things are horrific for the people suffering it. And it is associated in all of those instances with specific sorts of bacteria getting out of balance. So the question mark then is it top down or is it bottom up? Where did the disturbance actually occur? So it could be that the person got a cold and a well-meaning GP gave the child some antibiotics because that seemed to be the right thing to do. You have an infection. And again, I'm not trying to castigate anyone or demean anyone's style of practice. All I'm suggesting is a hypothetical possibility that could set this thing off. Because if we give the antibiotic for the bacteria that's not there because it was a viral infection in the first place, but the antibiotics having an anti-inflammatory aspect actually helped get them over the virus, but along the way knocked out a whole bunch of these good commensal bacteria, and it left an alteration vacuum, which then created a chronic disturbance upregulating these Peyer's patches. And so that might lead you to keep over creating antibodies that over a period of time led to some degree of autoimmune disease attacking your own tissue. So it's a really interesting way of thinking about it.
And for like those people playing at home, that although like you're talking about Crohn's disease and lupus and other sort of diagnosable autoimmune issues, like we could lump food sensitivity and intolerances in that same spectrum.
Absolutely, we can. So again, these sets of bacteria, along with it, it's basically saying is that the gut, these Peyer's patches are helping continuously select antibodies to protect us from disease-causing pathogens. But if we select the wrong set of antibodies, they may actually help cause disease-causing pathogens. As well as that, any of the inflammation with the dysregulation of those bacteria that damages the gut lining creates leaking. And proteins from partially digested food, if they leak into the bloodstream, will then start a different form of immune cascade, leading to antibodies against the food, so that when you see it in the future, your immune system goes, hey, you're a funny protein. You were there when that funny bacteria was going on. I'm going to punch you in the face because you're not meant to be here. And that could be egg, or it could be, dairy product. It could be any food. Like I've had patients turn up with an allergy response to chicken, rice, and bananas. I've only had one. And this patient happened to be a very high intensity triathlete, worked at a really high level, was an age grouper in her 40s, but really good at it, very intense, and also worked at a high level in a bank. And so there was a lot of stress going on. And my expectation, because we never got to the bottom of how she created these things, because I gave her the results of the blood test, and she went, well, those are all the things I eat when training, so I'm not even going to do it, and never came back. But my theory about it is, of course, that the stress on her body from the high intensity activity drove inflammation, driving the leaking in the gut lining, and created the Peyer's patches when they were activated to deal with the threat, to create antibodies against the food that was constantly coming in. So it kind of confused a normal thing with a threat thing, and then created an antibody against it, leading to the dysregulation. So
it's a fun little spiral.
Well, yeah, absolutely. And so again, the points that I'm wanting to get across is we've got both a gut front end problem, but it relates not only to the immune system, but the environment that's being created by ourselves, and what we do and how we are treating ourselves. And so I'm going to bring up another document in a moment that talks about sleep and detoxification. And I think it interplays very nicely with the Peyer's patches, because fundamentally, if you don't sleep well, this allows for hyperactive left brain and imbalance to right brain and dysregulation of your immune system. We'll, in a moment, have a bit of a discussion about it. Okay.
Well, off the back of that, I mean, we had a conversation last week about a patient of mine who has dystonia. So she gets triggered by sound, light, just about everything. Life's pretty miserable for her, but essentially an overactivity in the left brain. And as soon as that gets even more activated, then she goes into a dystonic response, and was responding really well to therapy until she celebrated one of her brother winning something, and then had a glass of champagne, and then a bit of gluten and dairy, and then rehab was going well, and then all of a sudden, bang, crash.
Yeah.
So like that gut inflammatory response further exacerbating her left brain overexcitability, creating more symptoms. Yeah.
And so that fits exactly what we're talking about here, especially with is it a bottom up or a top down model? Now, in her instance, we can argue both. And the reason we can argue both is this hyperactive left brain is shown to be very capable of driving autoimmune responses and dysregulating the Th1, Th2 immune system balance. So if we overactivate that brain, we get a lot more inflammatory cascade responses, and that could mean that we're getting a bigger antibody response against the things that she was sensitive to. Now, the other way is quite capable of being argued, because alcohol in of itself is shown to kill off certain of your good commensal bacteria, which are a bit fragile. And so by knocking those bacteria out, we're actually potentially imbalancing the biome that then stimulates the sentinel Peyer's patches to make more of these antibodies, which drives another inflammatory cascade. And what we've seen from like the Parkinson's research is that there is a reverse flow from the gut back to the brain that shows inappropriate bacteria or antibodies to the bacteria are partially responsible, suggested to be a cause of Parkinsonian type disorders in the actual brain of the patient. So again, I think I mentioned last time that antibodies to gluten are shown to cause a potential form of ataxia called gluten-induced cerebellar ataxia that can cause dystonic type movements and dysregulation of muscle. So the problem for us at this moment is we can argue several different vectors to actually describe why she had these particular symptoms kicking in post celebration. Either way, I think that the gut model definitely is associated, that those Paz patches are probably being dysregulated and creating the wrong antibody responses for her. We've also got the possibility that she's actually already developed an autoimmune condition because of this Th1, Th2 immune system imbalance. And most likely, with the excess left brain, it's suppressing the Th3 or T regulatory cells, which are meant to be actually saying, hey, slow down, let's go about the business. Everything's cool here. Don't punch them in the face. And that's the purpose of Treg cells. They're meant to say, yeah, this is how we do it. Not don't fight. And we just kind of clean up the act. But yeah, we just need further data on this particular patients to see where we're going to go.
Yeah. Well, we've put some things in place. I'll report back next week.
Cool.